Vielen Dank, everybody. It's been quite a journey so far. Um, it's been almost 20 years since I started working on Kettle, and it's been quite a journey. Thank you for that wonderful introduction, Stefan. Today, I wanted to talk a little bit about a couple of new exciting things that I'm working on. Obviously, um, you asked me to talk about Neo4j. That's such a pleasure. Um, and yeah, also talk about a little bit how the world has changed in those 20 years and the challenges that are coming towards us from the data orchestration, data integration, ETL space. And I want to talk a little bit about what we're doing to try to experiment with software and see how we can face those challenges. Neo4j has been quite an investment in software. Um, let's say that many millions of dollars have been invested in Neo4j, headquartered in Silicon Valley in San Mateo, and our other main office is in Malmo, Sweden. It's a Swedish company originally. And Neo4j created the label property graph. I'll explain a little bit about how that goes. And it's quite a fast-growing company with thousands of customers, and we have a variety of solutions for you running on your own servers in the cloud, or even with Neo4j Aura. You know, you can just look up Neo4j Aura, uh, type in your credit card, and get started right after this presentation. And our motto at Neo4j is that graphs are everywhere, right? Every one of us, all things are connected to other things and other people. Um, and for us at Neo4j, these relationships are actually just as important or even more important than the items themselves. And Gartner, for whatever it's worth, says that graph analytics will grow very fast in the next couple of years because the questions that we want answered are getting more and more complicated, and it's not even practical, even possible to use SQL queries for that. And I'll talk a little bit about that as well, why that is the case. So in our platforms, we have which is an open core platform, open source platform actually. So all our drivers and API are very much open source, Apache licensed. We have discovery visualization tools, administration, graph algorithms, a whole data science tools, and also data integration at the bottom, not just through plugins in Kettle and Hop, but also in a variety of ways with bulk loaders, with various kinds of possibilities. Um, my colleagues just released last week a new book called Graph Databases for Dummies. Um, Not to say that you are dummies, but this dumbs it down to the bare essentials. It's a great book. Another great book by Mark and Amy, my colleagues, is Graph Algorithms, which dive deeper into a couple of the graph algorithms that I'll be touching upon later. The server itself that we have is multi-database, so it's capable of not just clustering, but through Neo4j Fabric also capable of doing, let's say, asynchronous loads and that kind of stuff, so that you can tweak the cluster for read and write loads accordingly. We do have a BI connector, it's a JDBC driver, very much like Kettle has one, which translates SQL into Cypher, into graph queries. And Neo4j Bloom is a web-based front-end tool which allows you to analyze the data. So for example, a simple example where Alice is part of a couple of departments. We store this typically in a relational database like this. So a relational database says it's relational, but actually it's columnar data, right? So it's tables which are linked through indexes usually but you have to do the linkage yourself. And graphs basically store the values in nodes with a certain label. In this case, Alice is of a labeled person. It's a node, and it belongs to it has a relationship with three nodes, department labels, and it has a relationship belongs to. So it's very much like you would draw something up in Irwin or any of these entity relational diagram tools. So a labeled property graph is as such that you can give nodes a label, right? And so they represent the objects in the graph, and relationships. They are basically drawn between two nodes, and they can also have a type, and they have a direction. So as you can see, one person loves the other person, and the other person. So it's a love story here, and but only one person lives with the other apparently, which is kind of weird. And so all these labels and all these nodes and relationships can have properties. So the name, the birth of date, and so on. Okay, it's a very simple thing. So here is the third normal form on the left hand side, and the graph form, let's say the graph model on the right hand side, showing you that you don't really have to learn too much differently. Where things become different is that once you have a graph model, is that you can run a whole bunch of what we call graph algorithms on top of Neo4j. And so the first one I want to mention is pathfinding. So pathfinding means that, okay, so I have, for example, two-person nodes, Stefan and me, for example, right? If we graph out all our history together, ever, all the attendees let's say all the PMUDs of the last X years, then you would say, okay, how are Matt and Stefan related? You can ask Neo4j a shortest path algorithm, for example, and it will find a number of paths that say, well, they both went to the Metao user meeting in Germany, right? And so this is one of the things that differentiates Neo4j from a relational database, because in a relational database, you have to know the relationship. You have to specifically run the query to include certain tables and relationships uh, between various tables to pick up that information and then derive that information. Why is is this important? Because of performance. So in a relational database, suppose that you go through a B-tree index on your index, and you need to do a couple of lookups. That's great. That's fast. Then you have joined two tables, two pieces of information. Once you go three, four, five levels deep, then you all of a sudden have two or three to the power five, and that exponentially slows down as you want to link more and more information. So a lot of these graph algorithms, they're simply impossible to execute. That's why Gartner says hard or impossible. A lot of these algorithms that I'm showing you on the Neo4j cluster would take a couple of milliseconds, right? So we have customers with billions of nodes and response times in the milliseconds. One typical example of pathfinding is the ability to do recommendations. So, for example, if you graph out all the possible interactions that the customers had on a website or a visitor, and all the products that they looked at, how can we recommend other products? So for those kinds of applications, we need to be able to respond very quickly. It cannot take a second or two. It needs to be like, hey, a couple of milliseconds, 10, 15 milliseconds, 50, you can make a case for that. But beyond that, it needs to be snappy, right? And so centrality, so how central is a node? So if you have these graphs, these complicated graphs, and graphs work best if you throw more and more information in them. You know, it's kind of like the reverse of a relational database, which tends to become more and more tedious and complicated. It's graphs work best if you know more about certain topics. Community detection, you know, how is information in general clustered? Um, Similarity, you know, and node embedding. Those are the typical things. And so if you go to neo4j.com, then you will find more about that. And my mouse just died completely. I don't know why. Give me a second, folks. This is kind of like annoying. It's a good thing I have a touchscreen. Uh, 1 second. I don't know. Batteries always have the habit of dying in the worst possible moments. My apologies. Let's get back to it. Okay, there we go. So yeah, as I was wanting to show you guys, let's jump to Neo4j use cases. If you go to the neo4j.com website, I wanted to include all of them in my presentation, but then I realized I might as well show you. So we have listed like a tremendous list of things, and you know you can take any of these topics like fraud detection. Like I don't know if any of you know about the Panama Papers. But those analyses were run on terabytes of data on Neo4j to figure out how the money was related to various lawyers and whatnot. And we've been doing similar things with regard to some financial scandals that you might have heard of recently in the last couple of days. Um, uh, Cisco is using us in telco to optimize network pathing of their routers. So we are used in a variety of, and all of these are basically using these graph algorithms underneath. All right, let's go back. Yeah, so that's what my job kind of is trying to find solutions built on top of that wonderful database. It's really doing something novel, something that hasn't been available to us ITers in the past. And so what we've been doing in the past couple of years is using Kettle. And I think we have about 2025 Kettle projects feeding data in and out of Neo4j in production for quite large customers often. And Yeah, talk to me about that if you want to know more. In parallel, we've been looking at from the Kettle community perspective about okay, so what are the new technology trends in those 20 years, and how can we address those needs? And so we looked at things like containerization, Docker and ecosystems around that, Kubernetes, Docker Compose, the various dialects. Cloud, you know, moving things out of your data center is a trend which keeps going. It seems to be inescapable almost for a lot of things. And serverless, that's popular for certain things. In the past years, people have been asking me, "Hey Matt, how do you do serverless with Kettle?" Kettle is, I think, it clocks in at 1 point, I don't know, 4 or 5 gigabytes at the moment. So it's quite big. So going from a monolithic program to a small process in general, how do you do that? Machine learning, AI, streaming, and in general a proliferation of technologies, right? A number of years, Hadoop was very popular. Now it's people seem to run a lot of the technology on Hadoop, like HDFS, Spark, and these technologies. Maybe a little bit less on Hadoop itself, but on Docker containers and Kubernetes. That doesn't mean that Hadoop is going away. It's a popular Apache project. So a lot of the technologies tend to stick around for quite a long time. And certainly in the Corona crisis, we see that we work with globally distributed teams, and we expect everything to be version control. It's one of the. So how did we kind of like say, how does this translate into new requirements? For containers, this certainly means that we need to make our processes a little bit less stateful. We can't just leave too much junk around. We need to have like containers that are standardized as much as possible. The more that we need to tweak them and customize them and configure them, and the more painful it is, and the harder it is. And this leans into cloud, because a lot of cloud now runs on Kubernetes and Docker. We need to standardize simpler architectures which can be run everywhere. And for serverless, it means we need to be very much smaller in size and in memory footprint. And I could also add to that, we need to be able to resize, and appropriately size our data orchestration footprints. All the things that we don't need, we should be able to remove it without any question. And machine learning AI is a particular challenge because that world evolves quite fast, and more and more machine learning libraries and possibilities in Python. So that's more of an integration perspective from the data orchestration tool perspective, right? Streaming is something which has been on the rise uh, quite well, last 5, 6, but it's always been growing and growing in popularity. And so we've seen the rise of a number of engines to do that, right? Uh, so Spark Streaming is a one that you might have heard of. Apache Flink, which is a very good engine for streaming. But also Google Cloud Dataflow and other technology is floating around to do that. The proliferation of technology means that we must plan for the next technology in our architecture right now, which means that we can't really make big bets on any sort of technology, because in a couple of years, something new might come along that's very useful. For globally distributed teams, standards and best practices are really crucial. And we need to support Git. I think that's clearly been the champion of version control over the last decade or so. Uh, it's rare that I see anything else out there. For the best practices requirements, version control, unit testing, integration testing, proper documentation, proper project management, those are all things that we looked at when we said, okay, let's take a look at Kettle and the community and see how we can um, create a new experiment. And that experiment, as I call it in this slide deck, is Hop. Hop is the Hop orchestration platform, and it tries to provide an answer to the challenges above, right? And so it started from a collection of sort of like kettle related code. I think it was part the 8.2 code base. It was part Hiromu Hota's web spoon code. There was a bunch of plugins, patches, and with the help of the community team members, we started developing without any worry about existing code. So the problem that we had when I was still at Pentao Hitachi was that we had thousands of customers to consider, and it's hard to break compatibility. Hop doesn't make that claim. It's not kettle compatible in any way. In fact, it's going to break a lot of stuff. Um, Uwe, who is following this presentation, has written a migration tool. If you're interested, it's actually quite good. More and more people have been testing it. But please consider that we built everything up from scratch, from the bottom up. And but we do have development website. One of the things that we've been doing in the last couple of weeks is a voting process on Apache Hub becoming part of the Apache Software Foundation Incubator Program. As of today, I think it's fair to say that Hop is now part of that because we successfully finished the votes and the proposal was accepted. So we're now in the process of migrating everything over to the Apache website. Hop software architecture is quite similar to Kettles in the sense that we stripped everything down to this core. So there are no more layers around that. So before we had Carafe and other bootloading processes around this framework. So now we just have three very clean kernels, and all the uh, everything that we can has been pushed out to plugins. So every database connection is a plugin now. Every step that you know in Kettle, which was part of the core, was part of the Kettle engine, is now part of it's now a plugin, and this means that these three layers are really plugins. And this is similar, except that we now have, instead of transformations and jobs, we have pipelines and workflows to be more in line with Apache Beam and other Apache projects in terminology. And also different is that we have engine types. We have a local engine, which is the standard Hop multi-threaded engine. We have a remote engine for remote execution, so that you can see in the GUI how your pipeline runs remotely. But we also have execution engines based on Apache Beam plugin for Spark, Flink, and Dataflow, both in batch and streaming. Um, some cool features is that so everything in the kitchen sink in Hop is 350 megabytes. But everything is a plugin, so everything under the plugins folder, the subdirectories, you can just kick that out and you still work. We have a new GUI. We start up in under 5 seconds and faster if you remove a bunch of plugins. Like I said, runtime engines for SparkFlink Dataflow. Uh, we have the ability to package everything in a single library, so a fat jar, as they call it, so that it's easy to be used in contexts like Spark. So if you do a Spark submit or a Flink run, or run something in Dataflow, it's easy to have a single library. And that was one of the reasons why we removed Apache Carafe from our builds. We have also built-in support for things like search projects, easy switching between projects, remembering the open tabs and stuff like that. Lifecycle environments, configuration management, not just from the user interface, but also from the command line, Git auditing, a simplified tool set, simplified metadata in JSON, configuration files also in JSON with a simple tree. Version control documentation. This has been quite a bit of work that our community has been doing. Is basically rebuilding the documentation from scratch in a version controlled way using ASCII doc. And we're also in the final stages of unifying the tin and fat client code bases, so that if you build Hop, that you're getting a Docker container. You can build a Docker container basically, which allows you to run web hop, what we call it, in your browser. All right, so how do I get my hands on it? Go to projecthop.org and you can download the latest snapshot. As I said, it's an experiment. We're not stable yet. We're not 1.0. We don't claim to be. We're still having a lot of fun with it. But we are right now in a sort of feature freeze mode to stabilize everything that we've been doing. So it's quite safe to use it right now. Not everything is going to be 100% there, but we would really appreciate your feedback if you could give it a shot. How do I install it? Just same as Kettle, I guess. Install OpenGDK 8, unzip. There you are. Documentation is on our project website. If and when we will move to hopapache.org, hopincubator.apache.org. We will leave a link over there, and we have a bunch of videos that were created in the getting started section and explanation. So you should be up and running.